A record is spinning at the rate of 15 RPMs, which is revolutions per minute. If a ladybug is sitting 8 centimeters from the center of the record, find the exact answer for the following. So here's a little visual, and actually these records were 45 RPMs to get it playing right, so this will be playing a little slow. Okay, what is the angular velocity of the ladybug in radians per second? So we're going to take the information we were given, which is 15 RPMs. So we've got 15 revolutions per minute. And we're going to do conversion fractions. We're supposed to give an exact answer, and we want to go to radians per second. So first of all, let's go ahead and take care of the time units. So 1 minute, put it on top so that the minutes will cancel, equals 60 seconds. Now we have revolutions per second, so we've got the seconds taken care of and we want to get it in radians. So we're going to get rid of revolutions. One revolution, if it goes around one time, how many radians is that? That's 2 pi radians. So now we're rid of revolutions, and we can see our units are radians per second. So let's just go ahead and combine the tops. We got 15 times 2 pi, so we have 30 pi, and that's over the denominator is 60, and that's going to be radians per second, and then we'd want to reduce that. And so 30 will go into 62 times. So we've got pi over 2 radians per second for our angular velocity of this ladybug. Now it says what is the speed of the ladybug, and we want that in centimeters per second. So we're going to again start with what we're given, which was 15, and that's revolutions per minute. And we want to get to radians per second, so again we're going to convert minutes to seconds. 1 minute is 60 seconds. So now we're in revolutions per second. We want to get that in centimeters. So to get that, we need to see when the ladybug makes 1 revolution, how far the ladybug has traveled in 1 revolution. And so we need to find the radius, and the ladybug is 8 centimeters from the center, so that's our radius. And so if they traveled all the way around once, that's a circumference, 2 pi r. So 1 revolution, as far as distance traveled in 1 revolution, is going to be 2 pi times 8 centimeters. So now we're rid of revolutions, and we have centimeters per second, which is what we wanted. So let's go ahead and see what we can do to combine. On the top, I'm going to go ahead and just do some reducing. This 2 times a 15 is 30, and that will go into 60 2 times. And then this 2 will go into 8 4 times. So kind of squished in there, but I did some reducing, and I'm left with 4 pi in the numerator. And then that's going to be centimeters per second, because the denominator is just down to 1. So how fast is the ladybug going? 4 pi centimeters per second. Okay, after 21 seconds, how far has the ladybug traveled? Well, that one should be pretty easy because we're going 4 pi centimeters per second, and we're going to multiply that by 21 seconds. And that will tell me how far the ladybug is traveling. And so 21 times 4, that's going to be 84 pi centimeters. Now our last question, after 21 seconds, what angle has the ladybug turned through? Well, let's go ahead and take our angular velocity then. That was pi over 2 from part A, radians per second, and we're going to go for 21 seconds. And so as we look at that, the seconds will cancel here, and the angle 21 pi over 2 radians.